Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of engineering chemistry. We'll dive into key concepts like corrosion, types, mechanisms and prevention. Slide 1, Corrosion, Types, Mechanisms and Prevention. Corrosion is the gradual destruction of a material, usually a metal, due to its chemical or electrochemical reaction with its surroundings. Think of your bicycle chain rusting if not oiled, that's corrosion in action. At a fundamental level, it's often an electrochemical process, involving the movement of electrons. Why is understanding corrosion important? Its significance is broad. 1. Structural weakening. Corroded metal loses strength, potentially leading to the failure of structures like bridges. 2. Economic impact. Repairing or replacing corroded items costs a lot of money across industries. 3. Operational issues. Corrosion in machinery can cause breakdowns and halt production. 4. Safety concerns. Leaks from corroded pipes carrying hazardous materials can be dangerous. 5. Resource loss. Valuable metals are lost as they turn into corrosion products. 6. Visual degradation. Rust makes things look old and damaged. 7. Product contamination. Corrosion can contaminate sensitive materials in some applications. While generally negative, there are a few advantages to corrosion in specific, controlled scenarios. 1. Protective layer formation, passivation. Some metals form a thin, protective oxide layer that prevents further corrosion. Think of how aluminum doesn't rust away completely. 2. Weathering steel. Certain steels are designed to rust in a way that creates a protective outer layer. 3. Surface preparation, etching. Controlled corrosion can be used to prepare metal surfaces for coatings. 4. Mineral extraction. Some industrial processes use corrosion-like reactions to extract metals. 5. Biodegradable implants. In medicine, some implants are designed to corrode slowly and safely within the body. 6. Catalysis. Corrosion products can sometimes speed up chemical reactions. 7. Artifact analysis. Corrosion patterns on old artifacts can help determine their history. However, the disadvantages are much more common and impactful. 1. Reduced strength. Corroded metal is weaker. 2. Component failure. Pipes and tanks can leak or break. 3. Higher maintenance costs. Regular repairs are needed. 4. Product spoilage. Corrosion can contaminate products. 5. Inefficient operation. Corroded parts can make machines work less effectively. 6. Safety risks. Failures due to corrosion can cause accidents. 7. Aesthetic damage. Rust looks bad. 8. Environmental pollution. Leaks from corrosion can harm the environment. 9. Increased weight. Sometimes, rust buildup can add weight. Slide 2. Types of corrosion. Corrosion doesn't happen in just one way. There are different types, each with its own characteristics. 1. Uniform corrosion. Corrosion that happens evenly across the entire surface. Express. Silver tarnishing. 2. Galvanic corrosion. Bimetallic corrosion occurs when two different metals are in contact in a conductive solution. Express. Corrosion where steel and copper meet in a wet pipe. 3. Crevice corrosion. Localized corrosion in small gaps or shielded areas. Express. Corrosion under a gasket. 4. Pitting corrosion. Creates small, localized holes. Express. Tiny holes on stainless steel in salty environments. 5. Intergranular corrosion. Corrosion along the grain boundaries of a metal. Express. Weakening of some stainless steels after certain heat treatments. 6. Stress corrosion cracking, SCC, cracking due to combined stress in a corrosive environment. Express. Failure of stressed alloys in specific chemicals. 7. Erosion corrosion. Wear and tear combined with corrosion due to moving fluids or particles. Express. Corrosion in pipes carrying abrasive slurries. Slide 3. Mechanisms of corrosion. Electrochemical corrosion. The most common way metals corrode is through an electrochemical process. Think of a simple battery. Corrosion involves similar components. Anode. The area where the metal loses electrons, oxidation. Express. Ion losing electrons. Cathode. The area where electrons are gained, reduction. Common reactions. Acidic solution. Hydrogen ions gain electrons to form hydrogen gas. Neutral, alkaline, with oxygen, oxygen reacts with water and electrons to form hydroxide ions. Electrolyte. A conductive solution, like water with salts, that allows ions to move. Electrical connection. The metal itself provides a path for electrons to flow from the anode to the cathode. The corrosion products, like rust, form when the metal ions from the anode react with substances formed at the cathode or present in the electrolyte. Slide 4. Factors affecting corrosion rate. How fast corrosion happens depends on several factors. 1. Metal's nature. More reactive metals corrode faster, think of the electrochemical series. 2. Environment. Acidity, salts, humidity, temperature, and pollutants all play a role. 3. Impurities. Impurities in the metal can create small corrosion cells. 4. Stress. Stressed areas corrode more easily. 5. Surface condition. Scratches can start corrosion. 6. Anode-cathode area ratio. A small anode and large cathode lead to rapid corrosion at the anode in galvanic corrosion. 7. Temperature. Higher temperatures generally speed up corrosion. Slide 5. Prevention of corrosion. We can fight corrosion using various prevention methods. 1. Material selection. Choosing corrosion-resistant materials. Express. Using stainless steel. 2. Surface coatings. Creating a barrier between the metal and the environment. Metallic. Galvanizing, zinc on steel, tinning, electroplating. Non-metallic. Paints, varnishes, enamels, plastics. 3. Cathodic protection. Making the metal the cathode in an electrochemical cell. Sacrificial anode. Using a more reactive metal that corrodes instead. Express. Magnesium blocks on steel ships. Impressed current. Using an external power source to supply electrons. 4. Anodic protection. Less common, using a controlled current to form a protective layer. 5. Corrosion inhibitors. Adding chemicals to the environment to slow corrosion. Express. Adding chemicals to cooling water. 6. Design modifications. Avoiding crevice, ensuring drainage, minimizing stress. 7. Environmental control. Reducing humidity, removing corrosive substances.